Alright guys, so again, one of our main ideas for this class is to look at math and seeing the structure of how things are built. So in this note, we want to focus on looking at structure from a table. So there are different types of functions in math that you can identify based on their structure and how they're built. So we're going to focus on three different functions today. The first one, which you've already seen quite a bit, is a linear function. Now a linear function has a couple of characteristics. First, you never see the same y value twice. So as you scan this table, here's your y value, your outputs. These are all going to be different. Second, when you find the pattern, between those you're going to have a constant plus or minus pattern. So with that, if I look at this table, if I find a pattern between all the y values, in this case I'm calling it t of x, notice how the pattern will be from -2 to 1, 1 to 4, 4 to 7. You see how the values are going up, so it's going to be a plus pattern, and it's going to be a +3 pattern every time. So +3, +3, +3, +3. So I have here a constant plus pattern. The second that I see that in a table, I know that I'm going to have a line, because we said that plus and minus patterns are going to be lines. Make it a little bit neater for you guys. Now as we move forward, this plus pattern, we're going to actually call this pattern here, it's actually called the first difference. And what that means is I'm finding the difference between each y value, and it just so happens that they happen to have the same difference of +3, +3, +3, which makes it a line. Now to finish this first note, I can plot these 5 points and get a picture of this function. So the point -2, 2 is the point -2, -2, so it's there. So it's here. And the point -1, 1 will be here. 0, 4 is there. 1, 7. And notice how as I plot my points, I can then connect them. You see the shape being formed and get a line. Again, the goal today is that you can look at a table and looking at how it's built off of these characteristics, you can identify that you have a line by just seeing the patterns and what inputs you have and outputs. Next, we have a quadratic function. This is a different kind of function. Now this function, when I look at a table, I'll see a couple of different things. First, for this function, you will see some of the same y values more than once. As an example, if I look at my example here, notice how I have a -3 y value, and then I have that -3 reappear. This is kind of a clue that I may have a quadratic function in this table for this example. So that's how you can kind of tell some clues for what you're looking at. The second thing is, for a quadratic function, you're not going to have a constant plus-minus pattern for the first difference. But if you find the second difference, in that case, you'll have a plus or minus constant pattern. For example, in this case, from 0 to -3, -3 to -4. So if I find a pattern, or the first difference in this case, this is going to be a -3. Then between -3 and -4, I go down one more, so that's -1 more. But then notice how from -4 to -3, I go back up by 1. So I'm adding 1. And then from -3 to 0, I'm going to add 3. So the first difference here is not constant. It's -3, -1, +1, +3. So this first difference here is not a constant plus or minus pattern. But what I can do is I can find the second difference. So I can now find the difference of this new list. So from -3 to -1, in that case, I'm going to be adding 2. From -1 to +1, again, I'm going to add 2. And from 1 to 3, I'm going to add 2. So that's how in this case, when I take the second difference, I'd end up getting a constant plus or minus pattern. So if the second difference is a constant plus or minus pattern, this is what tells me if I have a quadratic function. So as far as my pattern here, this would be a plus 2 second difference. When I see that pattern, I know I'm going to have a quadratic. Now this is new to you, but a quadratic function will have a specific shape. And I'm going to give you this note. It's going to have a U shape. A U shape. Now it can be a U shape or an upside down U, but it will have a U shape of some kind. Now to check that, let's go ahead and plot these points here on the grid. And then when we come back into class, we'll use Desmos to verify what we get. So let's plot these 5 points. 0, negative 2 will be here. And then the point minus 1, minus 3 will be minus 1, minus 3 is there. And I'll go a little faster on these points. The point 0, minus 4 will be, oops, sorry guys, I made a mistake. This first point, minus 2, 0, should actually be minus 2, 0, it should be here. So this first point, I made a mistake. See, we all make mistakes. Let me erase that point. So it should be minus 2, 0. And then I get 0, minus 4. 1, minus 3 is here. And then 2, 0. So notice as I plot these 5 points on the grid, look at what's happening with the points. I'm going to get a shape that looks like a smiley face. And if I connect these points with a smooth curve, so not pointy, if I make it smooth, see, I get a U shape. So to summarize this first note, and there's one more to go, but we'll stop here for a second. When you have a linear function, you're going to have a constant plus or minus first difference. When you have a quadratic function, you're going to have a constant plus or minus second difference. That's how you can identify who you have from a table.